Hi everyone, we are super excited to solve some absolute value equation word problems. We have learned how to solve absolute value equations, but it's going to be even more exciting when we incorporate a word problem into the mix. So let's get started because I know you guys already want to get going on this. Okay, so in our first word problem, it says a recent poll suggests that 47% of American citizens are going to vote for a certain presidential candidate. Typically, the percentage is within 4% of the actual election results. What are the highest and lowest percentages that might support the candidate? Set up an absolute value equation to model the situation and solve the equation. Is the candidate guaranteed a victory? Why or why not? Whoa, that was a lot to read. So let's see if we can break this down and make it a little bit more easier to interpret what we're supposed to do. So typically in math word problems, the thing that pops out at you that's very important is when you see numbers in the problem. So if you see any numbers in the problem, that probably is going to be used somewhere in our word problem. Now, keep in mind that absolute value equations typically are in the format like the ones that we've been doing, the problems that I gave you, kind of look like this. They kind of look like, okay, they look like x minus, oh, sorry, you can't see it, JK, lol. All right, they look like x plus or minus a number of some sort equals another number. So it's going to be, in the word problem, so it will always be x minus some number that we don't know yet, but we will find out later. So x minus a number equals a different number, which I'll make that a different color so it's not as confusing. So the things I've underlined, those are going to be in place of some number that we're filling in. Okay, and the hardest thing about these problems, you guys, is setting up the equation. After we set the equation, you're basically going to be doing what we did in the examples right before this. So the hardest thing is setting up this equation. So let's see if we can make sense of this problem. So do you see a number in the problem that pops out at you? Let's see. I'll zoom in. Do you see anything in the problem that might help us solve? Do you guys see it? I see it too, you guys. Oh, man, you're so smart. Okay, so a number in the problem that I instantly see is 47%. Okay, so we know that the poll suggests that 47% of the people might vote for this unknown presidential candidate that we don't know yet. Okay, so I don't know. I'm just going to pick a random color. I'm going to underline that number in this pretty purple color. Looks like a nice presidential purple color, right? Okay, but anyways, also the next number I spot is this 4%, okay, which I like to color code, so I'm going to color this nice kind of salmon color. It's making me hungry. I want some salmon now. I love salmon. But anyway, so I see those numbers. Now, before we solve the problem, it says, what are the highest and lowest percentages that might support the candidate? Okay, so if I know that the percentage that they think it's going to be is 47%. Okay, it says typically this percentage is within 4% of the actual election results. Okay, now the reason why they say that is because when they ever do a poll, like I'm sure if you heard a poll about high school students, you're like, they didn't poll me. Like they said 20% of high school students love math or something like that. But they didn't poll me, even though probably it's more like 100% of high school students like math because math is awesome. But anyways, they cannot poll every single high schooler. So they'll give you a percent about high schoolers, but they probably didn't ask you. So there's something in statistics called a margin of error, which means the statistics they gave you might not be completely correct because they didn't get to poll every single person that they were talking about, which is called the population that they're polling. But anyway, so this 4% is called a margin of error, and that means that since they didn't poll anyone, this number could go up by 4% or down by 4%. So let's figure out the range, the highest and lowest percentage that this presidential candidate might be voted into office. So let's think about the lowest percent. So if we could be 4% under 47%, what would be the lowest percent it could be? Holy hot dog, you guys. It is 43%. So the lowest percent is 43%. Okay? And then the highest percent will be 4 above 47, which what's 4 above 47? You guys are like math geniuses. I don't even know why I teach you anymore. So this is 51%. Correct. Okay, so this candidate could be 47% chance of being voted in office. It could also be somewhere around 43% or somewhere around 51%. So we kind of have a range here, which could be problematic for this presidential candidate. We'll have to see. Okay, so we did that first part. What are the highest and lowest percentages that might support the candidate? Now it's telling us to set up an absolute value equation to model this situation and solve the equation. Okay. So what we did when we were solving this, what did you do with this 4% to get 43 and 51? You did subtract it to get 43 and added it to get 51. Okay, so let's think about an absolute value equation. What part of the equation, when we're solving, uses the same number, but one time when we solve it's positive, and one time when we solve, it's negative? Is it the part inside of absolute value or the part that is equal to absolute value? What part, when we solve and break it down into two equations, changes signs? Because the 4, one time is positive and one time is negative. It is the part that it equals to. You guys are correct. Guys, so the number that will always go in that spot is the number that changes signs, okay, or that you have to add in the problem and subtract. Okay, because this one we subtracted 4 to get that, and this one we added 4 to get that. Okay, so this part of our equation is always going to be that number that stays the same but switches signs. Okay, so this one is the number that changes signs. Changes signs. You have to say it all formal and everything. It sounds cooler, right? Okay. And then, in order to get these two numbers, okay, so first of all, these are the answers to the questions, you guys. 43 and 51 is the answer. That is the highest and lowest percent that the person can be voted into office. Okay, and typically in problems, when we solve, what part of the problem tells us the answer? Like when we solve, we say something equals 5, or something equals 10, or something equals 12, or whatever it is when we solve for this special thing. Okay, typically when we solve for things, we solve for variables. Okay, so the 43 and 51 in the very end, when we get done solving your absolute value equation, will be what x equals. So in the end, our answer should be x equals 43 and x equals 51. Okay, which I'm going to kind of set up my absolute value equation so I can kind of figure this out. So I know it's going to be x minus some number equals, well, the number that changes signs is that 4%. So I'm going to go ahead and fill that in. Okay, remember when we solve an absolute value equation, we break it down into two parts. On one side, we write this number. On the other side, we change the sign. And don't forget, we write this part of the equation twice. So we know it's going to be x minus something equals 4. And we know it's going to be x minus something, because remember, this part repeats 2 times. Holy hot dog, right? X minus something equals, on this side, what happens to the positive 4? It does transform into a negative 4. Whoa. My marker's going somewhere. Okay. Okay. So that makes sense because one time we subtracted 4 and one time we added 4. Okay, and when we get done, you guys, I'm going to try to squeeze it in the bottom to see if we end up getting that. We'll see. So we know one of my answers should be 51 and one should be 43. So I'm going to write 51 over here and one should be 43. So when we get done, that's our answer. Okay, so that's my goal. So let's see if we can get to there. Okay, now what's the only other number that we haven't used in the problem? It is that 47. Okay, this number right here, you all, is the number in the problem that never changes, ever. Okay, that 47, one time we did 47 minus 4. So one time we did 47 minus 4 to get 43. And one time we did 47 plus 4 to get 51. Okay, so the number that goes here is the number that stays the same and does not change. Okay, so this number is the number that does not change. So does not change. Stays the same. Or you could write stays the same. whatever makes more sense to you. So in this case, the number that didn't change when I was solving is the 47. So I'm going to slide that bad boy on in here. All right, and that's kind of how our absolute value equations are going to be set up when we have a word problem. All right, and remember, we're going to write x minus 47 on both sides of this nifty equation. All right, guys, let's solve this thing. And don't forget, at the very end, we better check our answers or the demon cats are coming for you. So at the end, we're going to check. Don't forget that. Okay, so how do I bring a negative 47 to the other side? I do add that bad boy on both sides. So I'm going to add 47 on both sides. Oh, yeah. So, sorry, I had a moment. So negative 47 plus 47 will cancel out and turn to 0. 4 plus 47 will give me 51. So guess what, you guys? We got the right answer. Yes. Our highest percent is over here, 51. Nice, you guys, nice. And see, this is the part where we did 47 plus 4 like we did here. Whoa. So this part is how we got that, which is pretty cool. Okay, now let's solve the other side. Like over here, I'm going to add that 47 on both sides. Nice. Which negative 47 plus 47 cancels and turns to 0. And negative 4 plus 47 will give me 43. Yes, we got it right. Awesome. And again, you guys, this is the part that I solved right here to get 43. Okay, this one came from over here. Okay, if that's too confusing to draw all those arrows, you don't have to. But that's where these things are coming from. All right, and the last step, obviously we better check our work to make sure these are not extraneous answers. Remember, we have to check for those so the demon cats won't get us. Okay, so I'm going to check on both sides. One where our x is 51, and one where x is 43. So what do you remember? Where do we substitute these values back into to figure out if they are legitimate answers and not sneaky little ninjas that are trying to trick us and play it off like their answer when they are not an answer? We do check it back in the original equation. This one right here, the original absolute value equation. We do not substitute these values into these two, so be careful. The demon cats will get you, okay? So be careful. Okay, so I'm going to set this up. So we're going to substitute 51, and for this x, so it'll be 51 minus 47. And let's see if we get 4. Let's see. Okay, 51 minus 47 gives me 4. Okay, so this will be 4. Oh, my color coding is off. No. Okay, and what is the absolute value of 4, you guys? It is 4. So yay, 4 will equal 4. Yes, we are excited and happy. So we draw a happy face. All right, same with this one. So let's check. All right, so we do 43. Oh, yeah, sorry. All right, 43 minus 47 equals 4. Let's see if we get 4. I hope we get 4. I'll be super upset if we don't. All right, so 43 minus 47, that will give me a negative 4. And guess what, you guys? What is the absolute value of negative 4? That's a 4. It's kind of a bad 4. Sorry, I need to work on my handwriting. All right, what is the absolute value of negative 4? It is 4. Yay! And 4 equals 4 every day. That ends in Y. Look at that. Nice job, you guys. That was awesome. So that's kind of how you do absolute value equation word problems. And they always will look like this. Like this right here is what they always will look like when you set it up. So the next problem, if you think you got that, I highly recommend that you try example. Well, it's not technically example 2, I guess, but example 2 on this paper. I highly recommend you try it on your own, and then you can fast forward through the video and see if you get it right. Way to go, you guys.